For decades, we treated the moon like a museum, a place humanity visited once to plant a flag, log a political achievement, and leave behind. Scientific models built during that era painted a specific picture: a geologically inactive, uniform desert made of gray dust and empty craters, a cold world where the major geological events ended billions of years ago. Treating the moon solely as an archive of past achievement obscured its functional future. While the world looked back at the Apollo footprints, new data began to suggest the lunar surface was a viable site for modern industry. That perspective shifted on June 1, 2024. China's Chang'e 6 spacecraft touched down inside the South Pole Aitken Basin. At 2,500 kilometers wide, it is an ancient, violent impact structure that exposes material from deep within the lunar crust. Over several days, the robotic probe drilled into the surface, packed nearly 2 kilograms of rock and soil, and launched it back into lunar orbit to return to Earth. Inside the lab, researchers found that these specific samples defied old models. The volcanic rocks were significantly younger than expected, meaning geological activity continued far longer than we thought. They also discovered the far side is dramatically drier than the side facing Earth, revealing the moon contains distinct, highly complex zones. This mission serves as the opening phase of a multi-decade architectural plan. China is now transitioning from short-term sample collection to a permanent, step-by-step strategy for lunar inhabitation. You cannot build an outpost on an alien world until you know exactly what you are standing on. The first requirement for any off-world construction is a high-resolution map of the terrain. Starting in 2007, China launched a series of orbital missions. Chang'e 1 and 2 mapped the surface and generated detailed geological models. In 2013, Chang'e 3 deployed a rover that tested mobility and gathered data directly from the harsh lunar dust. This is a schematic showing the logistical hurdle of exploring the moon's far side. The moon itself acts as a massive physical shield, creating a complete radio blackout zone that blocks direct communication with Earth. To solve this, the Chang'e 4 mission positioned a dedicated relay satellite in a halo orbit far behind the moon. This allowed a robotic lander to operate on the hidden side by bouncing the signal around the physical obstruction. Establishing that permanent data link cleared the primary infrastructural bottleneck. Operators on Earth could now safely direct heavy industrial activity anywhere on the lunar surface. The next logistical barrier is supply. A permanent base requires local utilities. That requirement directed engineers to the rugged topography of the lunar South Pole. Because the moon has virtually no axial tilt, the floors of deep craters near the poles never see sunlight. In these permanently shadowed regions, temperatures plunge below -170 degrees Celsius. Trapped inside these deep freeze environments is material delivered by ancient comet impacts. Billions of years of accumulated water ice sits perfectly preserved in the darkness. This diagram illustrates why water is the single most valuable resource in space. H2O can be broken down. It provides oxygen for life support and hydrogen for power. Combined, those same elements create highly volatile rocket fuel. Traditional wheeled rovers struggle in these rocky, steep environments. So for the 2026 Chang'e 7 mission, China is deploying a specialized hopping robot. By leaping across the terrain, it can descend into the darkest craters to physically prospect for this ice. Proving that accessible ice exists there transforms the moon into a functional, self-sustaining fueling depot. Even with local water, you still need physical structures. Launching heavy building materials out of Earth's gravity well costs fuel, money, and time. The economic solution is a concept called in situ resource utilization. This strategy relies on surviving using only the raw materials found at the destination. The upcoming Chang'e 8 mission is designed to test this. Engineers will test concentrated sunlight, harness extreme heat, and advanced manufacturing systems to melt raw lunar dust into solid construction bricks. Manufacturing these materials on site allows autonomous robots to pave landing pads and stack radiation shields long before the first human crews even launch. The mapping probes, the communication relays, the water prospectors, and the regolith bricks function as interlocking components of a single engineering blueprint. That blueprint is the International Lunar Research Station. It's a plan for a permanent surface habitat. To keep crews alive through the freezing 2-week-long lunar nights, researchers are already studying specialized nuclear power systems to integrate into the grid. The moon functions as the physical infrastructure required to support deeper solar system exploration. By following this exact sequence, mapping, communicating, fueling, and building, humanity is assembling its first functional industrial outpost on another world. The steps are already in motion. Do you think a permanent extraterrestrial future is decades away, or is it actively unfolding right now? Let me know your thoughts in the comments.